Here's our goal for this segment. We want to prove if we join two lists and then map F along them, it's the same as mapping F along each of the lists and then joining the results. And in order to do that, we have two sub-goals. We have to prove that result for the empty list, and we have to prove the result for x cons x's, assuming it holds for x's. Let's start off with the empty list case. Here you can see our goal. Let's have a look at what happens on the left-hand side. On the left-hand side, we have the empty list plus y's. By the definition of plus on the empty list, that's the same as y's. So on the left-hand side, it's map F applied to that, which is equal to map F on y's. So that's the left-hand side. What about the right-hand side? Well, what we have there is map F on the empty list plus map F y's. But map F on the empty list is the empty list. So that is the empty list plus map F y's, which by the first clause for plus is the same as map F y's. So we have the left-hand side and the right-hand side are both equal to map F y's. So we have proved the first goal. Let's get back to the second goal. Our second goal is to prove the property for x colon x's, assuming the property already holds for x's. So let's move back and write that proof now. Let's take a look at what we have on the left-hand side here. We have map of F applied to x colon x's plus y's. Now by the definition here, that is the same as map F x colon x's plus y's. And by the definition of map F, that's the same as f of x colon map F on x's plus y's. So that's the left-hand side. What about the right-hand side? Here we have map F applied to x colon x's, which we know is f of x applied to map F x's, and that is joined with map F y's. But by the definition of plus again, this is the same as f of x colon map F x's plus map F y's. So this is the right-hand side. So each of them has at the front f of x, and then following on the left-hand side we have map F on x's plus y's, which is this. And on the right-hand side we have map F x's plus map F y's, which is this. So precisely by the assumption we're able to say that the tail of the left-hand side is equal to the tail of the right-hand side. So we're able to say that left-hand side equals right-hand side as we wanted. So we've shown the proof for the empty list, and we've shown the proof for x colon x's, assuming the proof for x's, and so we have the result that we wanted, that if you join two lists together and perform a map, that's the same as mapping on each list separately and joining the results.